Okay, so in 6.6 we're actually going to use our factoring. And we're going to use our factoring to solve higher order equations. So up to now you've likely solved linear equations that have just your variable to the first power. So they'd have just x or just y or just m or whatever your variable was. But there'd be no exponents on that variable. So the first way we're going to learn how to solve quadratics, that's when your variable's raised to the second power, is by factoring. So the standard form of a quadratic equation, and this is the standard form of any polynomial equation, is having it set equal to 0. So that's our quadratic. We saw this when we factored. The standard form, the difference between just our factoring problems and our problems today is that they need to be equal to 0 to start. Now you've got to be careful. You don't want to start confusing the two directions. Up to this point, our directions have said factor. And there is no equal sign in our problem. So we just went and we set up our parentheses. That's the end. That's factoring. Versus today, our directions are going to say solve, and we're starting with equations. So the first thing we talked about on the first day of class was the difference between an expression and an equation. We factor expressions. We solve equations. Equations have equal signs. So what we're going to do is we're going to go on this property right here, this zero factor property, that says if I'm multiplying two things together and the answer is 0, one of those two things, or maybe both of them, have to be 0. So if I'm multiplying two things together and the solution is 0, it means one of those two things at least is 0. Because I can't multiply two non-zero numbers together and get 0. Like I'd have to have 5 times 0. Or 0 times 6. 0 has to be part of that multiplication problem in order for the answer to be 0. Now, what have we been doing when we factored? We've just been setting up multiplication problems the whole time. That's how those two things tie together. Factoring sets up multiplication problems. So if I want a multiplication problem equal to 0, all I have to do is factor. So here are your steps for solving a polynomial equation. The first step is to clear fractions. That actually, your book doesn't have any of those problems anymore. But the big place you want to make sure you start when these problems say solve and have an equal sign is that it has to be in standard form. Higher order equations for us, for now, have to be equal to 0 if we're going to be solving by factoring. And then we're going to factor, and you'll see we're just going to set each factor equal to 0. So the first problems you actually have are already factored for you. That's the easy kind. That's someone did all of the legwork for you. Now just because it's factored doesn't mean you can get going. What you're really looking for to start is that it's equal to 0. It's got to be in that standard form. If that equaled anything but 0, we'd have a lot of work in this problem actually. You'd have to FOIL it, you'd have to move that one number over, they'd have to refactor it. But it's equal to 0, we're okay to start. So this is like the last step of all the problems. You've got your factors, it's equal to 0. To find your solutions, you take any factor that has a variable and you set it individually equal to 0. Because with our zero factor property, if these two factors multiply to be 0, one of them has to be 0. So I've got my factors, it's equal to 0, set each factor with a variable equal to 0 and solve it. So if I have x plus 5 equals 0 to solve that, I just subtract 5 from both sides. So there's one of my solutions, x equals negative 5. To get my other solution, I'm going to add 3 to both sides so I get x equals positive 3. So there's a couple of different ways you can write your answers. I usually just write x equals and then separate answers with a comma. The way you're going to see it in your book, or the way you may have written it before, is as a set, where you use the squiggly brackets and then write your pair of numbers. Either one of those, you don't have to do both. Either one of those are acceptable. What I don't want to see is this. Because if you use regular parentheses, that says it's an ordered pair. One of them's x, one of them's y. We don't have x's and y's. We have all x's. So if you want to use a set, just make sure you use the squiggly brackets. If you can't draw them perfectly, just squiggly lines. Or just x equals in the numbers. Either of those will work. So I get my factors. It has to be equal to 0. I set each factor with a variable equal to 0. And so for this first problem, I got two solutions. Now for B, again, there's a couple things I want to look at in this before I get going. You will waste a ton of test time if you start by multiplying this out. This problem is set up for you to just go to the home stretch, get your answer. Because it's factored and it's equal to 0. So that means I'm going to be able to go ahead and get my answers. Now in this problem there are 3 factors. There's a GCF and then there's my 2 binomial factors. How many of those 3 factors do you think I have to set equal to 0? I heard a 3. What do you say, Devin? 2? Why do you say 2? You could. It's going to create a little bit of extra work if you do that, but you could. Anyone have any other thoughts? There's something I've been saying over and over about what you set equal to 0. It's got to have something with it if you're going to set it equal to 0. A variable. If it doesn't have a variable, it's not going to give us an answer, because let's say I took this 3 and I set it equal to 0. Is there anything to solve there? No. Is that true? No. So that doesn't give me anything. I have to have a variable with that factor for it to give me an answer. Now, yes, if you distributed the 3 into one of the factors, you're just going to have to reduce at the end and you're going to get the same answers. So there'd be nothing wrong if you did that first, but it's just creating a little bit of extra work. So I don't have to worry about the 3, no variable, it doesn't give me an answer. So there's only 2 of these factors that I have to set equal to 0. 2x minus 1 and x plus 6. So even though there's 3 factors, I'm only getting 2 solutions here. Now this first factor is the one that more people get wrong just for simple algebra. This is a 2-step equation. So I don't just get my answer in 1 step like I did with these first 2 factors. First thing you have to do is move that 1 over to the other side. So I'm going to add 1. So I have 2x equals 1. Second step, divide by that coefficient. Divide by 2. So x equals 1/2. Now the second answer is a 1-step equation. All I have to do is subtract the 6. So my 2 answers are that x equals 1/2 and negative 6, or you could write it as a set with the squiggly brackets. Either or. And the reason I switched the order when I went to the set is you usually do smallest then largest, but you don't have to. Ayana. Nothing. It does not affect your answer. Because like Devin was saying, she wanted to distribute the 3 into the parentheses, which they'd only go into 1 set. But think about it. If I distributed the 3, I'd have 6x minus 3 equals 0. What's going to happen when I solve it? I'm going to add the 3. So I have 6x equals 3. Divide by 6. Yeah, it's still 1/2. It reduces. So it doesn't affect your answer. So we don't have to use it. If you do, again, you get the same thing. You're just creating extra work. Any other questions so far? All right, now C. Again, there's 3, maybe 4 factors in this problem. How many, if we're calling this 4x one factor, how many of these factors do I have to set equal to 0? Got 2. Tiffany, how many? 3. Ayana, change it to 3. Why is this one 3? It's got the variable with it. So these are very similar looking problems. This one only has 2 answers. This one's actually going to have 3. Because of the x. When it's got a variable, that factor gives me an answer. So I'm going to take 4x, set it equal to 0, x minus 16 equal to 0, and 5x plus 1 equal to 0. So you have to have factors. That's one of the really big key things here. You have to have factors. And then we take each factor that has a variable, set it equal to 0, and solve it. So 4x equals to 0. What's going to be my solution from that equation? X equals 0. You're going to divide both sides by 4. You get x equals 0. Here's just a hint. Whenever you have a monomial factor on one of these problems, so it doesn't have a plus or minus, it's just that one term, that has a variable with it, it always gives the solution 0. So whether this was 10x, negative 3x, or just x by itself out front, it's always going to have the solution 0. This next one's our one step, so we can just go ahead and add 16 to both sides. I'm going to get x equals a positive 16. And then this last factor is a two-step, so I'm going to start by subtracting 1. So I get 5x equals negative 1. It's two-step when you have a coefficient in front of that x. Divide both sides by 5. So this time I have three solutions, 0, 16, and negative 1/5. Or if you're going for set notation, again, you usually go smallest to largest. And that's how you'll probably see it in the back of your book. But I'm okay if your set's not in order here, or if you just list them out. But in the back of your book, you'll likely see your set smallest to largest. So, any questions so far? Now that's our bubblegum world. It's our bubblegum world because someone did all the factoring for us. But we know how to factor. We've just spent a week and a half or 2 weeks, I don't know, yeah, 2 weeks, learning all about factoring. So how these problems are more likely to come to you. Now I will give you problems like that where it has the factors. You have to know how many factors to set equal to 0 and how to solve. But what your problems are more likely to look like are D. This is a quadratic. It's a quadratic equation because it has x squared as its highest power of x. So up to this point, each of these little equations that we make is a linear equation. This is quadratic because it has x squared. There's two things you need to do to get back to this step for quadratics. The first thing is you always want to make sure it's in standard form, which is equal to 0. If it's not equal to 0, that's the first thing you've got to correct. The second step, which people tend to forget, is we need factors. You can't just set, the mistake people make is they set x squared equal to 0, they set negative 5x equal to 0, and then they just kind of leave the 6 off because it doesn't have a variable. You have to have factors. It's a 0 factor property that we're using. So if I look at my 2 steps for solving a quadratic by factoring, first step, it has to be equal to 0. Well, I've got that in this problem. So then I can move on to the second step, which says I need to factor this. Devin. So those are going to be the numbers that go into your factors. Negative 2, negative 3. So it's going to be x minus 2, x minus 3. So this is a trinomial. It's got 3 terms, which means after a GCF, we're going to try the AC method. So remember, for your quiz on Wednesday, look at how many terms you have to see which type of factoring to do. So 3 terms, I'd go to my AC method. So I'm looking for a pair of numbers that multiplies to 6 and at the same time adds up to b, which is negative 5. So I'm looking for that pair that multiplies to 6 and adds to negative 5. Now this problem you can use that shortcut on, so you don't necessarily need all this work. And why can I use my shortcut factoring method on this problem? A is 1. So you can go through the whole grouping phase, but the shortcut method says start each factor with your variable, and then just end them with whatever your pair is. So x minus 2, x minus 3. And that will save you some time, but the people who factor everything by grouping are usually very efficient at it anyway, and it's going to work out to be the same. But we can skip that step on this problem because a equals 1. So this is all set up. This is all of our setup to solve this problem. And now it looks like our other examples where we have our factors and they're equal to 0. So we could take each factor and set it equal to 0. And quadratics can have up to 2 solutions. They can also have 1 solution. They can also have no solution, but we're not going to see those until Unit 3. No, Unit 4 even. So my two answers for x are that x equals 2 or x equals 3. And as a set, do your squiggles, 2, 3. So for most of these quadratics, you have to do that legwork, where you get it equal to 0 and then you create the factors. And again, when we get to Unit 4, we'll use this to solve some application problems. Questions? All right, E, x squared equals negative 6x minus 9. So I have an equation because I have an equal sign. The other thing I see in this equation is that x squared. When it has x squared as its highest power of x, this is a quadratic equation again. So there's 2 steps to our setup before we can get going. Devin. So you have to subtract. So that will work. My only caution is if you subtract the x squared to get it over to the other side, then a equals negative 1, and you have to go through full grouping. Yeah. So when you're looking at a problem like this, and your first step is to get it equal to 0 because it's a quadratic, I always look at the term that has the x squared. If a is already positive, that's our best case scenario. Positive 1 is the absolute. You can't get better than a equals 1 on a quadratic for factoring. So when I look at this, I see my x squared has a equal to positive 1, best case scenario. So I don't want to move it. I want to bring the other 2 over. It seems like extra work at the beginning, but it's going to save you so much work when you get down to the factoring step. So I always look for where x squared is, what a is. If it's positive, leave that, bring everything else over to join it. So if I want to get the negative 6x over to the other side, how am I going to do that? Add 6x. Not right with the real pen. So I'm going to bring 6x over. How am I going to get the negative 9 over to the other side? Same thing, I'm going to use a positive 9, just the opposite sign. So it's going to look like x squared plus 6x plus 9 equals 0. Now, if you'd gone the other way and you subtracted the x squared, it would be 0 equals negative x squared minus 6x minus 9. There's a really quick fix for that, which I can do because I have an equation. If I want to get rid of the negative in front of my x squared, if I was factoring, I'd have to factor out a negative. But because I have an equation, my other option is if I divide everything by negative 1, it flips their signs around and comes back to this. It is extra work. That's why if x squared has a positive a, just leave it and bring everything else over to join it. But you could always fix the negative, the extra negative. All right, so my first step for solving quadratics by factoring is to set it equal to 0. What's the second step? Factor it. Notice the method is called solving by factoring. So we have to factor in there somewhere. So step 2 is to factor. Now if I look at this problem, again, I could use the shortcut because a equals 1. So with 3 terms, I'm looking for that pair, that AC pair. So I'm looking for 2 numbers that multiply to 9 and add to 6. 3 and 3. Now if you want to go through grouping, you can. On your quiz, I can tell you there will be a problem that you have to use the full AC method where you go through all the grouping. Guaranteed. Guaranteed you'll see one of those. But because a equals 1, I can go right to my factors, where they start with x and they end with my pair. Now notice the equal for 0 was earlier in my problem. Don't start putting equal to 0 on the end of every problem. These problems are solved versus everything else we've done is factor. When you factor, if the directions were factor, you end there. Don't get solutions. But because we're solving, we've got that extra step. So how many factors do I have to set equal to 0 in this problem? 2. So if I set my two factors equal to 0, I have x plus 3 equals 0, and x plus 3 equals 0. What are my solutions? Negative 3 and negative 3. So if you tell me my answer is negative 3 and negative 3, sound like a broken record. So in this case, even though there's two factors with variables, it doesn't give me two different solutions. So you could certainly work them both out. You're going to get the same answer both times. This problem only has one answer. Remember, I said quadratics can have no answers, which we won't see till later. One answer if my factors are the same, or two answers. It's just one solution here, x equals negative 3. Questions? That's the only time one of these is going to have one solution, is if you get the same exact factor twice. Other than that, most of the time we get two. Okay, for F, our directions are solve the equation. What's my first step going to be?
Move the 10 over.
Rob says move the 10 over. Anyone have a different place they want to start? Why are you going to move the 10 over?
So it's equal to 0.
So it's equal to 0. What types of equations do we have to set equal to 0? Quadratic. What did we say was a key characteristic of a quadratic equation? Squared. It's got your variable squared. What does this problem not have? A variable squared. And I put this one in here because once we get rolling on what we're doing, we try to do that for everything. And you're certainly not the only one who said, move that 10 over. This is not a quadratic. I just put this in here so you're really paying attention to what you're doing. This equation is linear because it has x to the first power, but no x squared. So we don't have to set it equal to 0. If we hadn't ever done this lesson, I could have given you this equation and 90% of you would have gotten it right. Think back before today. How would I solve this equation? What would I do? DeAndre. Move 7 to the other side. So I have 4x equals 3, and then what? Divide by 4. This looks like the end to each of these quadratics. But don't overthink every problem. It didn't have an x squared in it, so I didn't need to go through the quadratic equation steps. It's just a linear equation. Don't overthink them. Does that make sense? So the times we're going to do that equal to 0 factor is if we have an x squared. If it doesn't have an x squared, what happens is people tend to, if they're going to get it correct, they move the 10 and then they move it back. So again, extra work, it'll get you there, but it's taking up some of your time. All right, so 2 more, and then we will have time for our classwork today. So F, 5x squared equals 6x. This is another one that people look at and tend to kind of blank on what you need to do, because unlike our other problems, it doesn't have 3 terms. But it doesn't have to have 3 terms to be quadratic. What characteristic do our quadratics have? Squared. They have that variable squared. So notice, having that x squared makes this quadratic. Even though it doesn't have 3 terms, that's okay. It's still a quadratic. And there's 2 steps to solve our quadratics. First, it's got to be equal to 0. That's how you solve quadratics by factoring. They have to be equal to 0. So which of those terms am I going to move? 6x. A is positive where it is. I would go ahead and leave it there. Bring the other term over to join it. So I'm going to subtract the 6x. So I have 5x squared minus 6x equals 0. So the first step for our quadratics, when we see that our equations have an x squared, is to set them equal to 0. And our second step, factor. So how am I going to factor 5x squared minus 6x? What do you say? You could. That's going to create more work if you try to use the AC method here. Any other thoughts? Kevin? Yeah, GCF. This is actually a much easier problem than the other ones. With the two terms, GCF, or in solving, we'd only have perfect squares. You'll never see the big perfect cubes in the solving problems. So for two terms, start with a GCF. So my greatest common factor here is x. Now it leaves me with 5x minus 6. And the only other possibility is a difference of two perfect squares, which this is not. So this problem is just a GCF. Just take out the x. How many solutions am I going to have to this problem? 2. There's two factors. They both have a variable, and if you recall, I said whenever that first factor is a monomial, it's always going to give the solution 0. And in this case, I don't even have to do any solving. As soon as I set it equal to 0, I've got x all by itself. X equals 0 is the solution. My second solution is going to come from this 5x minus 6 is equal to 0. That's the two-step. To get your answer, the first step is to add the constant, so I'm going to add the 6. So I get 5x equals 6, and then divide both sides by 5. So I get x equals 0, there's 6/5. Or if you're doing your sets, 0, 6/5. So every type of factoring can come in here. And then finally for h, I have 25x squared minus 49. Is this one quadratic? Yes, it's got that x squared in it as its highest power of x. So our two steps for solving a quadratic. First is it has to be equal to 0. Okay, well this one is equal to 0. So that step's taken care of already. Second step is we've got to factor it. So I need to remember how to factor 25x squared minus 49. Ayana. 5 and 7, close. So what type of factoring? You remember what that's called? Difference of perfect squares. So where are you getting a 5 from? Why is 5 in there? 25 is 5 times 5, so it's just going to be 5 squared and 7 squared. What else do I need on there? X. Where's the x going? With the 5. Remember, if a single term has both the number and the variable, when we break it up, we should have both the number and the variable there. So then what do my factors look like? Okay, 5x minus 7 is one of them, and 5x plus 7. So this goes back to 6.4, our difference of two perfect squares. Two terms, subtraction, I can rewrite each term as something squared. How many solutions am I going to have? I have 1, I have 2. Are these exactly the same factor? No, so they are going to give two different solutions. They're just going to be the opposite signs. That's what's really going to happen. So I have 5x minus 7 equals 0, and 5x plus 7 equals 0. They are going to give two different solutions. So on the first factor, I'm going to start by adding the 7. So I have 5x equals 7. Divide both sides by 5. X equals 7/5. Second one, I'm going to start by subtracting the 7. Again, the only thing that's different with your perfect squares is the sign. Negative 7 divided by 5. So x equals negative 7/5. So x equals 7/5 or negative 7/5. If you're doing your set, your squiggles, separate them with a comma. Yes, Rob.
Previous classes, I've just been allowed to write x equals plus or minus.
Yes.
Does that work?
Absolutely. We'll get to that more when we solve using the quadratic formula and by completing the square in Unit 4. Any other questions? right, then it's your turn.